Hi guys, this is 11.1 Solving Linear Systems by Graphing. Our essential question is how can you find the solution of a system of linear equations by graphing? Our shortest answer is basically you graph the lines. Initial value, rise over run, and then wherever those two lines may or may not intersect. So basically, if you have one intersection, that means you have one solution. Coincident lines have infinite solutions. It's basically they're the same line itself. Or parallel lines, they never cross one another, therefore there will never be a solution. So we're going to go over those. Now, just a note, some of the language differs, but for most people, a system of linear equations is also called a linear system or just systems. Sometimes that happens. Now, it consists of two or more linear equations. So in life, we always compare different companies to each other, and sometimes there's different fees, different charges per month or per day, depending on the company. And we like to compare them and see what happens throughout time because our money is always on our minds. All right. Now, a solution of a system of linear equations with two variables is any ordered pair, basically x, comma, y. That satisfies the equations in the system. That means whenever it says satisfy, always think has to be true. Okay. Now, a consistent system is a system with at least one solution. So, um, consistent. So every time they cross at that one particular moment in time, that's what that word kind of brings into my head. I don't know what you think of when you hear the word consistent system. But yeah, every time there's always that one solution, that one x value, and that one output value, that y value, that always seems to be true. Okay. Now, consistent systems can be either independent or dependent. Okay. Now, an independent system has exactly one solution. All right. The graph of an independent system consists of two lines that intersect at exactly one point. Okay. So basically, like that. All right. So you have like f of x, and then you have your other uh, function g of x. Now, a dependent system has infinitely many solutions. Basically, two coincident, hey, they're finally using that word, coincident lines, which is basically the same line. Okay. Now, a system that has no solutions is known as inconsistent. So here's this line, here's this line. So here's f of x, here's g of x, and then like in geometry, we usually indicate they're parallel by those little tally marks, those little arrows that I put inside. They'll never touch one another. All right, so example one, we have these two functions. Notice how we have slope-intercept form for y equals 2x minus 3, and then we have standard form for 3y plus 6x equals 18. Now, if you want to graph standard form, you can totally do that. Again, that's the whole like what is if y is 0, what's x going to be, and then you have your intercepts. Or if you want, we can rewrite this. So I'm going to go ahead and rewrite it since we already learned this back at the beginning of the year. And I'm going to put this in terms of y. So I'm going to get y all by himself. So let's get rid of the 6x. What you do to one side, do to the other. We got negative 6x plus 18. How do you get rid of a dividing or multiplying 3? Divide. What you do to one side, do to the other. Y equals, that's a y. Negative 6 divided by 3 is negative 2. Don't forget the x. And 18 divided by 3 is 6. Ah, I know how to graph that, right? That's definitely slope-intercept form. All right, so let's go ahead and graph y here. Let's go ahead and graph this guy right here. So our b is at negative 2. That's our intercept. And then our slope, um, our rate of change is 2. So in this sense, it's up 2 over 1. Okay, up 2 over 1, up 2 over 1, up 2 over 1. I'm just giving myself some points so I can graph correctly and make sure I don't go too off into the boondocks. There we go. So again, that's the first guy. Now, the second guy, I'm going to use a different color here, kind of color code it. I'm going to use blue. All right, I'm going to use blue. There we go. You're my boy, Blue. So my intercept is my b, and that's at positive 6 right there. And then my rate of change, or my slope of my graph, is negative 2. That means down 2, 1, 2 over 1. Okay, down 2 over 1, down 2 over 1. And I already noticed that one of my points landed onto the line itself, the other line that I'm comparing it to, which is pretty helpful. Now, that's a terrible line, I totally know. But I already know that. Look at that. That's my solution. Okay, so graphically, they intersect at 2, comma 2. So my solution is at 2, comma 2. That's an ordered pair. So that'll make them true. Okay. All right. So example 2. Again, what's my b? If you want to rewrite this, we can. I'll do it real quick. How to get rid of a negative 4x? What you do to one side, do to the other. I want to get 2y equaling 4x plus 6. Now you could always graph this by using standard form, but I know background wise, a lot of you guys are used to the whole slope intercept form, so I'm kind of complimenting your normal backgrounds. If you want to do the intercepts, we can. I think in the next one, I'll go ahead and do intercepts for you, okay? But basically, you should get down to this point, and look at that. You guys notice something about them? It looks like, yeah, we have the same equations, right? So if they are the same, they're the same line, okay? You can actually save yourself a lot of time. If you notice that they're the same line, you already know. So therefore, infinite amount of solutions is going to be your answer because they're the same line. They're always touching each other. So our b's are at 3, and our slope is up 2 over 1, 1, 2 over 1. And basically, even on a graph, you would notice they have all the same characteristics, and they would both coexist at that same line. All right, so infinite amount of solutions. All right, example 3. And like I promised, I'm going to go ahead and solve or rewrite, or not rewrite, the standard form. I'm going to show you the intercept way. So remember, if x, let me clean this up so you can see. I'm going to go ahead and do this. Okay, so if x equaled 0, what would y be? Okay, so negative 4x is going to be negative 4 times 0 plus 2y equals 4. And basically, that's just going to leave you with 2y equaling 4. And we all know that we divide by 2, what you do to one side, or 2 times what gets me 4, and 4 divided by 2 is 2, because 2 times 2 would give me 4. So basically, here's my first coordinate. This would be known as my y-intercept, 0, comma 2, which is right here. And then let's think about my x-intercept. So again, this is my y-intercept that I just did. And then my x-intercept. Now, if you want, you can totally rewrite the standard form equation right here and get into slope-intercept if you want, or you can do it this way. So if y is 0, then you have negative 4x plus 2y, which is 0 in this situation, equaling 4. Now you're going to have negative 4x equaling 4, division property, what you do to one side, and then x equals negative 1. So you should get negative 1, comma 0, which is right here, okay? All right, so that is my y-intercept and x-intercept. That will be my line right there. You have to forgive me for my crooked lines. It's actually really difficult to draw this digitally. All right, so there's my first line, or my not my first equation, my second one really. But my first one I'll do in blue. Okay, so my b is 3. Rise over run is up 2 over 1. Hey, that's I think very similar to my slope on my other line. Interesting. There we go. So what we notice here, again, it's not a perfect line here, guys. So forgive me for that. Believe me, I tried. All right. But what you noticed here is their slopes are identical, their b's are not the same, or their intercepts aren't the same. That means we have no solutions. If you look at the graph, they don't cross one another at any point in time. These guys have no solutions. Okay, they're parallel lines. They will never cross one another. All right, so your to number one. Now, it's a bit messy. If you want, you can try to rewrite them to where you have y equals mx plus or minus b. You could totally try to do that. Um, how do you get rid of this multiplying 2 right here, right? And then what you do to one side, do the other. It's okay with fractions, all right? Don't be afraid of fractions. So that's my little hint for you. Again, -5 over 2 is really just down 5 over 2 and 10 divided by 2, right? So rewrite these. You can always rewrite them into slope intercept. That'll probably be the hardest part about this problem is just rewriting them and then graph them. Now you can use Desmos if you want. Again, open up another window or another tab, go to Desmos, and then just type them in, and you can graph them and get your solution visually. All right, so interpreting graphs of linear systems to solve problems. Now, the real world kicks in, all right? So, Video Club A charges $10 for membership and $4 per movie. Now, $10 just to be a member, I'm thinking that's the initial cost, all right? My intercept might be. Now, $4 per movie, I'm thinking that's my rate of change, that's my slope, okay? Now, Club B, let me use a different color here because I like to get color coded with these. Video Club B charges 15 bucks per membership, so that's their initial cost, plus $3 per movie, which I'm thinking, again, my rate, all right, my slope. So let's go ahead and create our system based off this verbal description. So we have, again, I'm going to call this f of x, all right, equals, let's see, $4 per movie plus the 10 bucks that they charge, right? So that's f of x. And then we'll call this g of x. This is going to represent Club B. They're at $3 per movie plus $15 for membership. Oh boy. All right, so let's go ahead and start graphing these guys. So for Club A, or Video Club A, they start at, again, $10 just for the charge. So that's a B right there, guys. Sorry. So $10 and then $3 for every, or $4 for every movie. Okay. So let's see. If we did 3, 4, what do I want to see? Let me pick a number that works really well here. It is rise over run, but I'm trying to be strategic here. I do know after the fifth video, 4 times 5 is 20, and then 20 plus 10 is 30. So I know that point will exist there. So I'm going to go ahead and try to draw my line respectively through there. Okay. So that's for f of x. So do you guys know how I did that? I picked 5 because I knew that 4 times 5 would give me 20. 20 plus the 10 would give me the 30. Okay, so that was a good point to really just kind of get myself a line going on. All right, so g of x, we start at 15 bucks, so that'll be up here, and they go up $3. So let me see if I can do some magic here. One, four, five, six, seven. Oof, it's not going to be pretty no matter what number I pick. What if I pick four, just out of curiosity? So 3 times 4 is 12 plus the 15, and that'll give me 27. Okay, $27. So let's try it. At 4, we'll be at $27, kind of like right around here-ish. Okay, and then if I graph it, oops, looks like I messed up right there. You know what? I just realized there's actually a really good number I can use. Silly Mr. Webb. Instead of using 4, let's use 5. Okay, just because 3 times 5 is 15, and 15 plus 15 is actually a nice divisible number or factorable number by 5. So 15 plus 15, that's 30. Hey, wow, 30. Wow, okay. So check us out. At 5 also, it's going to cost us 30 bucks too. Huh. So again, my pen is just having a field day right now. I thought I fixed it, wiped my computer, did all that fun stuff, and still doing it. All right, so that's g of x. All right, but notice how the two lines intersect in the situation. So how many movie rentals will it cost? Will the cost be the same at both clubs, and what is that cost? So in 5 movies, the cost will be the same, and it will cost 30 bucks. And that's why we say ordered pair. Okay, in 5 movies, the cost will be the same, and that's at $30. All right, so that's our solution, and that's just graphing for you. All right, so in these contextual problems, you really have to think about your number sense and knowing what numbers you can really use to graph, or just have a ruler and get that really good line going on. It's more difficult for me because I'm on that digital platform. But yeah, all right, so here's your turn number two. Same thing. You have two different people. They're reading the same book. We have some of our initial values, and then we have our rates. Okay. So just be aware of who's who and who's doing what. Okay. And then create your system, create your two equations, again, slope intercept form. And then also notice that we're talking about reading a book. And we're talking about pages every night. So how many nights? So label your nights for every night, right? And then pages read um, will be your output. Okay, so notice how you're labeling them. All right, and then you are responsible for figuring out what units you want to go up by, and then just start graphing and spend some time on it and let me know how you're doing. All right, guys. Have a great day. If you have any questions, let me know.